got to see quite a bit of what this Radia application is. Um, so what we're working on now is that so that was the parametrized undulator example in Cerrepo. And we're going to be extending those examples to the dipole magnet, the quadrupole magnet, and wiggler, and potentially more. We're improving the parallelization process to use OpenMP. We're going to develop a CAD interface to Radia using code so that code such as Opera can import STL files, improve the core physics engine to allow modeling of hysteresis and superconducting magnets. There's going to be an interface with Cerrepo. So we're going to interface that to an optimization engine. And if you see our next webinar by Chris Hall, he's going to show you this RSOpt that we've been developing. Then also the ability to run Radia on external clusters such as NERSC. So let me just check one more time to see if we're back, and if not, then I guess we'll move to the question and answer period. Well, I don't seem to be getting it back at the moment, so sorry about that. Okay, well, in any case, it's already been 40 minutes, so this is close to the amount of I was moving a little slower than I thought I might. So here we are. So I think we could spend some time answering questions for now.
Yeah. So thank you, Boaz. And apologies for the Sirepo server thing. We're trying to figure out what's going on there right now. So if anybody has any questions, please type them into the Q&A. We already have one question from Bruna Diviaccio, and that is it possible to import in Radia Cerrepo a design developed with Radia Mathematica?
With Radia Mathematica, that takes a little bit of work, actually. So we went through the process of translating all of the Radia Mathematica examples into Python. So if you go to that, if you look in the repository, in the Python, in the code repository, and then in our examples repository, you'll see the Python examples. But I don't believe at the moment there's an automated translation. There are these dump files that could be read in. I don't know. You may be able to export a dump file in Mathematica and then read that into Python. I'm not 100% sure that works, but I think that may work.
Great. And we have another question from Yuri Ivanyushenkov. Is there an option for electromagnetic undulators?
For electromagnetic undulators, we haven't built an example of that, but everything that's available in Radia, we plan to support in our Cerrepo application, and you can certainly do that in the Python interface to Radia.
So got a few more questions. So Suko Kangtawang asked, and I apologize if I'm mispronouncing your name, is the magnetic field uniform along the transverse direction?
Along the transverse, no, it's going to fall off because if you think it's finite, the pole widths are finite. So if you go out past the pole width and continue on, you're going to see the field fall off to zero after that.
Okay, great. So Lucas Igor Balthazar asked, is it only possible to simulate a planar undulator?
At the moment, this parametrized undulator is only a planar undulator, but one of the models that we have a number of models that we're looking at making parameterized. An Apple II, for example, and we've been working with this segmented adaptive gap undulators. So yeah, we certainly plan to add more complex undulators to our set of examples here.
All right. So Ali Mogadam asks, is there any option for optimization, such as changing the thickness of the pole and calculating the peak field?
So right now you have to do that by hand. So as I was showing you, you could go in and change that yourself, and then it outputs the peak field, it outputs the field along the axis. But yeah, if you want to do an optimization, that is one of the plans we have already some examples of doing that in the Jupyter notebook, but we plan to integrate that into Cerrepo as well within the next year or two, basically. Yeah.
Okay, cool. Great. So we've got two more questions, and then if you have any more questions, Boaz, do you have your contact information on the next slide?
Right.
Great. So so we've got two more questions, and if you have any more questions, you can follow up with Boaz directly by email at bnash@radiasoft.net. So the first question is from Michael Sigrist. How much does the Sirepo interface support custom geometries? Are we limited to changing parameters of examples?
Yeah, so we've been trying to design this to be useful to people, and we're not finished with it. But right now, there's the parameterized undulators available. The 2D mode, you can build your own. So there is a mode where you could design whatever you want, but it's not a fully featured. It may not be quite ready for a professional magnet designer to use, but it certainly has some good capabilities already. And so you can also read in a dump file. So if you design something externally in Python, you can read that in and then use Cerrepo to visualize it. So that's available. And then yeah, basically we're still adding features, but we have an intention to support as wide a variety of ways of designing magnets as we can.
And one last question from João Ramos. Is there any configuration to simulate superconducting magnets in Sirepo?
Yes, I mean, well, I guess it's the same answer, that to the extent it can be done in Radia, then you can read it in and visualize it, but we don't have the parameterized version of it right now. But if we are shown interest, if people are interested, then we can quickly add additional parameterized examples of things like superconducting undulators. Yes.
Okay, great. Thank you, Boaz, for that presentation on MPMD. I apologize about the issue we ran into with the Sirepo server. We're trying to diagnose that now. And thank you all for attending. You will receive about a week from now an email with a copy of this recording. Be on the lookout for the announcement for the next webinar that Chris Hall is going to give on June 2nd on using our RSOpt Python library for running large-scale optimization problems. So again, thank you very much for attending, and I look forward to seeing you at the next webinar.